Now the second example which we are going to study, it is trace x square into 2a minus y is equal to y. For tracing this curve, again we require 6 points. First one symmetry, second origin, points other than origin, asymptotes, region of upsides and shape of the curve. So the first point, it is symmetry. First point is symmetry. As the given equation contains even and only one power of x, and therefore this curve is symmetric about y-axis, because in this equation only at one place x square is there, and as power is even, and therefore this curve is symmetric about y-axis. So I will write given curve is symmetric, given curve is symmetric about y-axis. Okay. Now the second point, it is origin. So in second point, what we do, we check whether origin is present on the given curve. How to assess? Put x is equal to 0, y is equal to 0. So put x is equal to 0, y is equal to 0 in the given equation. Then what will happen? X is 0, y is 0, LHS is equal to RHS, and therefore curve, equation of curve gets satisfied, and therefore curve passes through origin. Curve passes through origin. Now once curve passes through origin, the next work is to find equation of tangent at origin. And how to find equation of tangent at origin? Equate lowest degree term to 0. Now we will consider the equation of given curve. So what is the equation? Consider 2ax square minus x square y is equal to y. So here for first term degree is 2, second term degree is 3, and this term degree is 3. So here lowest degree term is only 1, and if I equate this lowest degree term to 0, sorry, we get 2ax square is equal to 0 implies x square is equal to 0, and this implies x is equal to 0. So for the given curve at origin, the tangent is x is equal to 0. It means y-axis is a tangent at origin for the given curve. Okay. Now we will proceed further for points other than origin. Points other than origin. Okay. Now how to obtain points other than origin? For getting point on x-axis, put y is equal to 0. For getting point on y-axis, put x is equal to 0. So first what we will do, to get point on x-axis, to get point on x-axis, to get point on x-axis, put y is equal to 0. And then I substitute y0 in the given equation. So what we will get? 2ax square is equal to 0, and this implies x square is equal to 0, and this implies x is equal to 0. So on x-axis, when we substitute y is equal to 0, we got x is equal to 0. Thus 0, 0 is the only point of intersection with x-axis. Now to get point on y-axis, to get point on y-axis, to get point on y-axis, put x is equal to 0. Put x is equal to 0. And when x is 0, in the given equation, we get y cube is equal to 0, and this implies y is equal to 0. So by putting x0, we got here y is equal to 0, and therefore origin is the only point of intersection. Origin is the only point with both axes. Origin is the only point with both axes. So there is no point other than origin, because with x-axis the point of intersection is origin, and with y-axis the point of intersection is origin. So there is no point other than origin, and therefore there is not necessary to calculate equation of tangent with or at the point other than origin. Okay. Now the next point is asymptote. Asymptote. So how to obtain asymptote? What is the exact procedure? The procedure is to get asymptote parallel to x-axis, equate the coefficient of highest power of x to 0. Similarly, to get asymptote parallel to y-axis, equate the coefficient of highest power of y to 0. So here, if I write the equation of given curve, I will get it as 2ax square minus x square y is equal to y2. Now in this equation, which is highest power of x? Yes, x square is there at two places. So highest power of x is 2. Then what I will do? I will take x square common. Then what is remaining? 2a minus 1, and which is equal to y2. Now highest power of x is x square and its coefficient is 2a minus 1. So to get asymptote parallel to x-axis, equate the coefficient of highest power of x to 0, and therefore 2a minus 1 is equal to 0, and this implies y is equal to 2a. So y is equal to 2a is an asymptote parallel to x-axis. Now to get asymptote parallel to y-axis, equate the coefficient of highest power of y to 0. But here the coefficient of highest power of y is 1, and it is a constant, and therefore asymptote parallel to y-axis is absent. Okay. Now the next point is region of absence. Region of absence. Region of absence. What is the procedure to test whether curve is present in a particular region? The procedure is, first step is plot the points of intersection. Second step is, if asymptote is present, then asymptote itself is one of the partition. Step number 3, draw the partitions. Step number 4, define the partitions. And step 5, in each partition, check the region whether curve is present or not. Okay. So the first part we will go for. We will plot the points of intersections. So now this is x-axis and y-axis. So which are the points of intersections? Here, first point of intersection is origin. Points other than origin, there is no point other than origin. So only 0, 0 is the point of intersection. Step number 2, if asymptote is present, then asymptote itself is one of the partition. So here asymptote is present, that is y is equal to 2a. So y is equal to 2a, it means this is the line which is parallel to x-axis. So this is the line y is equal to 2a. It means this point is 0, 2. Okay, 0, 2. Now, as asymptote is parallel to x-axis, and therefore we do the partitions parallel to x-axis. So here point of intersection is origin. So already I have drawn x-axis. It means there are total 3 partitions. Okay. So this is partition 1, this is partition 2, and this is partition 3. Now after getting 3 partitions, now we have to check whether curve present in each partition. For that, what we do? We will define each partition. How we define this first partition? This point is origin. So this first partition is defined as y less than 0 because below x-axis always value of y is negative. This partition we can define it as 0 less than y less than 2a because in this interval y ranges from 0 to 2a. And this third partition we can define it as y greater than 2a, isn't it? Now as here partitions are parallel to x-axis, to check the region, we should select the value of y. Now in first region, we will choose the value of y as minus a because here value of y it is negative, it is less than 0 and therefore we will choose value of y is minus a. When y is minus a, what is value of x square from the given equation? So x square is equal to y cube upon 2a minus 1. Okay. Now when y is minus a, this numerator is negative. And here 2a minus of minus a, so it is 3a, that is positive, but numerator is negative and therefore in first partition x square is negative. And if x square is negative, curve is absent in this whole partition. Okay. Now, in second partition, choose value of y is a. When y is a, what is x square? Here it is a cube, that is positive. 2a minus a, so it is plus a, so this is positive. So when y is a, x square is positive, it means curve is present in middle partition. In third partition, we will choose the value of y is 3a, and when y is 3a, numerator is positive, denominator is negative, so x square is negative, and as x square is negative, curve is absent in this whole third partition. So curve is present only in one partition, and that is middle partition. Is it understood? Now we will go to next point, that is shape of the curve. Next point is shape of the curve. Now while tracing the curve, first we will draw coordinate system. So x-axis and y-axis. Now the first point it is symmetry, we will see at the last. The second point it is origin. Yes, for the given curve origin is present. So I will represent this origin as a dot. At origin, in second point, we got equation of tangent as x is equal to 0. Origin, equation of tangent is x is equal to 0. It means x-axis is tangent. Y-axis is tangent at origin. If y-axis is tangent at origin, the curve will have a shape either on this side or on this side, isn't it? But below this x-axis, curve is absent. As below x-axis, curve is absent, and therefore here we can erase this part. Okay. Now, so this is about origin. The third point is points other than origin, but there is no point other than origin. The fourth point is asymptote. Yes, asymptote is present, and what is that asymptote? Y is equal to 2a. So I will draw the line y is equal to 2a, and this is asymptote. If this line represents asymptote, then probable curves are either on this side or it will be on this side, either on this side again this side. But after 2a, in third partition, curve is absent, and in third partition, if curve is absent, so we will erase this part. Here also we will erase this part. Okay. And as this line is asymptote, and what is the definition of asymptote? It is a line which touches the curve at infinite distance, and therefore I have drawn the curve like this. So distance between this curve and line, it tends to 0. Okay. Now, if two curves lies in same partition, we will join these two curves. So the actual curve is like this. And here, as curve is symmetric about y-axis, whatever we have drawn on left side, we have to draw on right side. Okay. So such type of origin which we got, such type of origin, it is called cusp. So this particular point, it is called cusp. Okay. So we have drawn this curve, and this line, it is asymptote. Just write it as asymptote. Okay. So now we will proceed further for example number 4.